All right, so here is your, here's your little purple paper. Remember, you were supposed to change this to x equals 2. And as you did these on Friday, I did go around and check them to make sure we were all on the right track. I'm not sure that everybody got to the point where they were finishing them, so I want to make sure that we all have them correct before we move forward. So we're graphing lines, which means you use a straight edge, they have arrows, they extend through each other, right? And some of us had great difficulty graphing some of these lines. One of the reasons I think that some of you struggled was because I asked you to try and graph these lines without putting everything in y equals mx plus b. I think there was still some confusion about that this morning, so I want to talk you back through those processes here to make sure we all get it. So first of all, you have to know the difference, whether this is horizontal or vertical, because that's number one. But then when we look at this line here, this is in your y minus y1 equals m times x minus x1. So if you do put this in y equals mx plus b, your y-intercept is 10. That's a problem, because your graph doesn't go to 10, and then you're guessing. Okay, so that's one reason why it doesn't always work for you. If you were going to write an equation in this form, it's called point-slope form because you need a point and a slope, right? So if it's already in that form, you can just do it backwards and get that out. So my ordered pair is, since this is x minus x1, my x value is 2, y minus y1, my y value is 6. And then this is my slope, and it's a negative 2. So I can plot the point 2, 6, and then from there I count the slope, and I go down 2 over 1, down 2 over 1. Instead of, it's the same process of graphing as it is in y equals mx plus b, you're just starting from a different point. Does that make sense? That way I don't make any mistakes putting it in the other form. And sometimes your y-intercept is a fraction or some weird number you can't do anything with. And I don't even need it. I don't need to do any work. So then after you graph the lines, you have to shade in the enclosed region. Well, there's 3 lines, so you should have a 3-sided figure in there. And this is what should be shaded. Okay, we all good on that one? All right. All right, good, good. So then here on this one, let me get my arrows back in there.
Wait, so the 6 middle lines, that's the middle one?
The what now?
Is that the middle of the graph? Oh, okay.
No, the axis is the same axis you have. Okay, so here I have 4 lines. So I have to have 4 lines graphed. And here, again, I can put this in y equals mx plus b, but I don't need to, all right? It is in standard form, and standard form can get you the intercepts very quickly. And I think when I talked you through it, everybody's like, oh, yeah, okay, I didn't know that. But then when you went forth and tried to do it on your own, it was a hot mess. So if I'm looking for the y-intercept is the y value when x is 0. So if I zero out this term, I get 2y equals 6, right? Which means y equals 3. So some people are writing it down like this, and then zero out the y, and you get 3x equals 6, so x equals 2. But this isn't how you write it down. If I write it down like that, that actually gives me 2 lines to graph, which is not what I'm trying to do. So that's not what we're trying to do. Then some people took that information and made it into one ordered pair with the 2 and the 3, and that's not what we're trying to do either. It gives you the intercepts. The intercepts is where it crosses the axis. So the x-intercept is 2. So I go to 2 on the x-axis, there's my point. Or the ordered pair is 2, 0. The y-intercept when x is 0 is 3. This is what the ordered pairs look like, which you wouldn't have to have written down. All you know is the y-intercept is 3, the x-intercept is 2. There's your 2 points. You draw the line through it. Okay? It's basic algebra 1. Then you get the other lines in there. Now then when you go to shade, you have 4 lines. Your shaded region should have 4 sides. I know I'm not shading here because this isn't enclosed because it keeps on going. I'm not shading here because this region doesn't have anything to do with this line. This is the region that is enclosed by all 4 lines at the same time. Okay, does that make sense? We good? All right, so let's look at number 3. All right, so let me get my arrows back in here. Now, here, my intercepts, when x is 0, y equals 3. When y is 0, x equals 3. So there are my 2 points to get that line. Here, when x is 0, y equals 6. When y is 0, I get 2x equals 6, so x equals 3. There by 2 points for that line. Okay? Everybody okay with that? And just know that that intercept thing, I mean, it works 100% of the time. It may not be helpful 100% of the time, and we'll look at that on the next one. It may not get you everything you need, but it got us all these lines, and then x equals 0 is your vertical line there. So then what I'm shading in is what's enclosed by those 3 lines, which is right here. Everybody good with that? All right, so let's look at the 4th one. Oh. So put in my little arrows here. All right, so when I start with this one, when x is 0, when x is 0, negative y equals 0, which means y would be 0. And when y is 0, x is 0. So the x and y intercept happen to be the same point. That happens when it's the origin. So using my intercepts only got me 1 point, and I have to have at least 2 to draw a line. So then I have to go do something else. I can get the slope. So if I move y over, gives me x equals y. What's the slope? 1, because that's y equals mx plus b if I flip it around, right? Slope is 1. So that gives me at least 1 more point. I can get my line. Plus, what do we call this thing here? Why is that a special line? It's the what?
Oh, it's the parent.
It's the parent function. Good. It's the parent function of the line. Okay, so then on this one, when x is 0, I get 2y equals 12, so y equals 6. And then when y is 0, x equals 12. Well, there's a problem, because that goes way off my graph, right? And so again, I don't get to guess, so I'm not going to be able to use both intercepts like I have on the other ones. It still works. It is the intercept. It just doesn't help me in this particular case. So this line is already graphed, and you've already had to figure it out a different way. What is the slope? So what is the slope of this line we're trying to graph right here? Negative 1/2, right? Because they go 1 down and over 2, so negative 1/2. So I want you to look at this line here. Isn't this ax plus by equals c? So if I just take negative a over b, guess what that gives you? The slope. Okay? Again, something else from standard form that's very, very handy. If you don't know that, which I'm quite sure you didn't because you didn't even know how to find the intercepts, that's okay. You could put it in y equals mx plus b and get the slope, and you already have the y-intercept anyway. But there are different ways to find that and find the other points that you need. So then we get that line graphed. Then we have to know that this is the vertical line. Once we have that, then we shade in. Now I'm not shading this in, even though it would cross the x-axis. I'd have an enclosed figure with the x-axis, but that wasn't my line. These are my 3 lines, so this is my enclosed region here. Okay, we good? Any questions? All righty. So you need to hang on to those and keep them handy because you're about to use them. I'm going to give you the paper that we're going to start on today. Yes. Actually, I think y'all refer to this as a packet because it's 2 pieces of paper stapled together. So I'm hoping this doesn't take up too much room in your binder and that you can carry it out because I know it'll be extra heavy since it has the staple in it and everything. Huh? I know. But there's only 8 problems, and the reason that it is this huge packet is because I was trying to give you lots of room.
So this is basically a standard.
Yes, something like that. That's exactly what I was saying. All right, so freshmen, your yellow papers need to be stacked up. 10th graders already got it from you, so don't freak out. All right, so let's look at this. First of all, I want you to look. Stop talking. I want you to look at number 1 and look at the lines that it gives you in number 1, and then look at 2, 3, and 4, and tell me what 1 through 4 have in common. They're all the same lines, right? And then look at 5 through 8. What do they have in common? They're all the same lines. Now, look back at 1 through 4. What do those match on your purple paper? Oh, number 1. That's why I said keep it handy. What do 5 through 8 match? Number 2. Okay. And So that I've learned my lesson with this activity and I've changed the lines up every year, but this is really good and I really like this. But the first time I gave it, I just kind of gave it as it was and was like, okay, we're going to graph the lines, we're going to shade, we're going to revolve, and wow, was that a complete disaster? Because if you don't graph the lines right, you don't even have the right figure. Then you try and revolve that thing, and it was just a really big hot mess. So we're going to make sure we all have the right lines now. Now we're going to go forth and do. But we're going to do number 2 together so you can make sure you understand exactly how to handle this to make it easier on yourself to visualize this stuff, and so that you aren't doing the wrong thing. So you need your pencil, and you need a straight edge, which your ID badge works great, and at least one colored pencil. There should be a box of colored pencils with erasers, like separate erasers and sharpeners in there. Grab all that stuff. And then on number 2, I want you with your pencil to graph the lines. Just graph the lines in number 2. Don't shade anything in yet. Just get the lines graphed, okay? And double check with what you did on your purple paper. It should match, but make sure you pay attention to the fact that the grids are different sizes. So you can't like count from the edge. Like really just plot the points and you can get the lines on there correctly. Also on some of these, I have moved the axes, not to confuse you, but to give you more room for things to fit. So pay attention to how you're actually graphing it. So just number 2, graph the lines, and then we'll wait for everybody to get that done. Yes? There was a quiz. You're going to be able to come in today after school? You have what? Okay. So tomorrow before school? Okay. Axes is plural. So axis, I'll write it up here. Axis, that's one. And then axes is plural. Okay. Because we don't say axes. Or axi, yeah, we'll say it later. Okay, so there are my lines. Now we're going to pretend like this blue is like my pencil, right? And we already know where to shade the original one. So now, but the reason I told you not to shade yet, I want you to use a color. It doesn't matter which one. It's not an art project. But when you shade it in. Don't color it in as dark as possible. Okay, you kind of want it to be a little bit transparent, but you want it to be different. So on mine, it can't look transparent just because of the markers I have, but just shade it in lightly. Don't make it the darkest you've ever colored anything in your life. And I wouldn't suggest using the markers. I would suggest using the matte pencils because they are erasable. I paid extra to get the erasable ones for that, so they would be forgiving. Now, for the rest of it, you can use your pencil, or it might actually be helpful either if you use the same color you just did, but like make some of the things we're about to do darker, or maybe use a different color. Like since I used yellow, I'm going to use a different color. Again, you don't have to use all the different colors in the world. You can do all of this with just your pencil in the end, but we're going to have extra lines on the paper than we did before, and it helps if you can separate the stuff a little bit. So if the color just makes it look different. Because on the first time that we did this stuff, we used, I just gave you points. We plotted the points, we got a polygon, and we revolved that, right? But now we have these lines that are still there, so we got to make sure we separate that from it. So I'm going to use a different color, and I'm going to outline the region that I got. So I'm going to outline my triangle in just a different color. Again, if I hadn't used yellow, like if I had used a lighter purple, I could just, with a matte pencil, you could actually just make that darker and use the same color. It's fine either way. Yeah, outline the shape so that you can get like a defined outline there. And then let's read what this says. So we've sketched and shaded, done. Basically, that's what we had done on our purple paper, right? Then it says revolve the shaded region about the x-axis. So what is being revolved? The shaded region. Does it say we are revolving the lines? No. Right now we have 3 lines graphed. When all is said and done, we will still have 3 lines. We may have other line segments, may have ellipses and some other things, but the lines themselves don't move. just the polygon that you outlined. Does that make sense to you? So when we're ready to revolve, we know it's about the x-axis. So after we've drawn and shaded, then our next step is to do what in the x-axis? Before we revolve. Right. And by doing what? How do I know where to plot them? We reflect it. So the next thing you do is reflect it in the x-axis. So if I'm 6 away, I've got to go 6 away on this side. There's my other point. Using a straight edge, do not do this freehand. I'm going to connect the points. Now, chances are pretty good that you already know what this is going to be and you could finish the drawing, but you're not always going to know what you're getting. Okay? You may think you do or you may be unsure. Here's how you make sure you've drawn all the ellipses, because that's really the biggest mistake after not knowing how to reflect things. The second biggest mistake is not having all of the ellipses there. I started with a triangle. It had 3 vertices, right? 2 of those vertices are attached to the axis of revolution. It's possible that none of them would be, but in this case 2 of them are. So since 2 of them are attached, I'm not making ellipses with them. This one that's not attached is making the ellipse. So I know I have 1 ellipse to draw. So before I start revolving anything, make sure you have in your mind how many ellipses you need in the end so you don't leave any off. Does that make sense to you? Figure out how many are attached. So the ones that are not attached create the ellipse. And I know that I reflected from here to here, so that's where my ellipse goes. It looks something like this. And so this is one reason why you don't want it to be shaded super dark, because then the ellipse that goes like behind it, if you can't even see that you're drawing anything there, it's going to throw off the look of your picture and you might be confusing yourself. Okay. Then the other thing that is really helpful, sometimes it may not be 100% necessary, but in some it is, so I would just do it every time, is plot the point that is the center of the ellipse. That way, that'll help you figure out what the height and the radius and those things are, so you'll know where the base, the middle of the base really is. Now, on some of these, you may be revolving around something that's not an axis. So if I'm going to revolve around the line x equals -3, then I would probably want to go ahead and draw in the line x equals -3, even maybe as a dotted line, so that I have it there and I can see that axis of revolution. Okay. So then after we do all this, it says to find the volume. What I want you to do here when I turn you loose in just a minute is go through. We're not going to find any volume today. Like, I don't even want you doing any calculations today in class. Not until you have everything drawn and revolved. Use the time in class to get in there and graph all the lines, shade them in, get things revolved. That way I can make sure that you understand what the pictures are. You can make sure you're doing it right. And then once all of them are drawn and revolved, then go back and do the actual math work that it's asking you to do. Does that make sense? Yes, sir. Oh, you are. I just didn't want to do, number 1 doesn't revolve, and so I didn't want to just do that one with you. Oh. So yeah, you're going to go back and do number 1, and then I would just, go and draw the lines, and then on number 1, that's all you have to do. You're not revolving. But then on number 2, graph the same lines, revolve it, move on to number 3, on to number 4, graph the lines, revolve it. Pay attention to whether or not I move the axes, because on some of them they are, okay? But the graph itself you should be able to tell where the x and y axis is. The graph itself, the original one will look the same for 2 sets of 4. Okay, any questions here? We good? Awesome.